Okay, so we're doing transformer cooling this week. It's going to be simple. I mean, it's not difficult stuff to understand. You should be able to get through it pretty quick. You should learn all you need from just reading the chapters. Uh, mhm. Once we finish student studying this week, we should know the various sources of heat in the transformer. We know that there's things in a transformer that cause heat, and we'll talk about those. We should know them by now. We'll discuss them a little more in depth. Just to recap, uh, we should be able to identify various methods of transformer cooling, identify different types of transformer cooling, um, and describe external devices that aid in transformer cooling. All these things are determined by what the transformers are doing, and how big they are and how much power they're converting. And so we'll talk about that uh, in a as we go through. For air-cooled transformers, now that's just simplest of the ones. I mean, it's just an a transformer sitting there in the air with air around it, and it's going to get hot. Well, what happens to hot air, right? Hot air will rise in the atmosphere. So when hot air arises away from the transformer, the cooler air would be pulled in below it. And that cooler air would then be next to the transformer and begin to be heated, drawing heat away from the transformer. Once the that heat begins to expand that air, it grows lighter and it starts to rise, pulling more cool air. And you get this convection heating going on, and it will carry off the heat of the transformers. These uh, control transformer types, for example, supply voltages to a motor. Uh, there's to motor starters, to similar equipment. Um, some of them have shell type, and with some of the core material around them, building a box around them, not in a box, but in a frame around the windings. Small transformers generally heat just a few watts, and so they don't create a lot of heat. Larger transformers are contacting are controlling power to a larger motor, and you know these are uh, interesting transformers. They're um, maybe feed multiple motor starters. I may do a number of jobs within a cabinet. Sometimes they're placed within the MCC cubicle, and they don't have an external case, so they're just there. Uh, and once again, just like I spoke a minute ago, they're cooled by convection. Warm air rises, pulling cool air in, which soaks up heat and begins to rise itself. Always remember in heat transfer, heat always moves from a warmer device to a colder device. Cold does not flow. Cold draws the heat away. And as the heat is distributed through an object, temperature is begins to decrease and fall. So, you know, when this convection happens, the cool air is drawing heat off of the transformer and expanding. It's not being pushed. So therefore, one of the things about that you need to know is if the transformer is dirty or if there's not good airflow, it's not going to have good heat transfer. And if you don't have good heat transfer, eventually that transformer will overheat and uh, uh, burn up. I mean, there's a certain level. You can look at the nameplate data or the technical data on a transformer. It'll tell you at what point the damage starts occurring in these temperature the windings of a transformer when they get to certain temperatures. I'm sorry, but you know. The as those things as convection works and carries heat off, it keeps them maintained to a nominal level. There should be a level that it should be able to be able to maintain. If it can't maintain that, you may have to add additional components. You may have to add, uh, pardon me, an aftermarket fan or something like that to push air by it, right? Notice it says right here that they must be periodically cleaned while uh, de-energized to get rid of the dirt and the dust and to block ventilation there, because that stuff will, if that stuff's in the way, or if you have a filter that's not been changed and air can't flow, the ventilation is not going to work. The air cooling is not going to work. Uh, so then we have large, small and large dry type power transformers for commercial and industrial use. These are built into a case. They have ventilation openings. We have to make sure we don't mount those in a way that the ventilation is blocked. We don't want to do that in any way, shape, or form. There's uh, you'll see a lot of those on around machines. If you walk up to a machine that uses power from the ceiling, a lot of times that power will go into a transformer and then down to the machine. And that transformer is one of these that it's been spoken of here. And usually, if you look at that casing, that box, that metal box that that transformer is mounted in, there'll be holes, pardon me, down low, and there'll be holes up high. And that allows cool air to come in at the bottom while hot air is able to escape at the top. If you had it boxed in to where only with one opening, it would be hard for air to circulate. And so it needs good ventilation where air can get in at the bottom and leave at the top. Uh, you know, some of these are used in unit substations, and they'll have a box, a little cubicle in there. I guess what they call it here, and it's a box in it, and they got a lot of area in there that allows air to flow and move so that the heat don't build up. You put a transformer in a small box, and there's not much room for air. Pardon me, it will heat up faster. Uh, so. Um, uh, and if you they are producing more heat because they're enclosed. If you have out in the open, there's a lot of air, but if you have an enclosure, even with air holes, that air has to be channeled and it can't move as fast. So once again, this dust and dirt will kind of want to stick to it. They build up an electrical charge around the transformer and and will begin to cling stuff with like static electricity, and you have to brush that off and clean it up if you notice it. Um, a lot of places I have been, there's air filters mounted on these enclosures, and there's a preventive maintenance procedure. You go by, you change out the air filter, and observe the uh, transformer itself, make sure it's still clean, change the air filters, and go on your way. And that keeps them, the air filter keeps them from being um, uh, uh, getting dirty and not conducting heat very well. So um, here is just an example of that. You have in the middle here, you've got a transformer, three phases. Uh, you know, uh, 4, 5, and 6 is showing the grounding bus, and 5 is the transformer. So you see it points to three different locations there, and so you got your high voltage section. This is where the power comes in from the source. Uh, okay, now we're assuming this is a step down transformer when I say that. Uh, and you have a transformer, you have the low voltage section, right? And this is where the output would be taken off of. And in between, it is converted, say, maybe from, in a case like this, uh, 7,000, 7,200 volts down to 480. Or maybe it's 480 down to 200 so that you can run a bank of machines. You don't know, and there's no way to tell, but you can see that there's limited airspace in here, and with limited airspace, you're more likely to heat up. That's why it's really important to make sure that these ventilations, you can't see it real good, but there's ventilation holes here in the bottom, and there's an air hole there. I can see ventilation holes in this back and the top, and so there's room for air to flow, but it's up to us to keep it clean. Okay. Uh, Convection and fan cooling for dry type transformers. Natural convection is used most of the time and at any time when it's at all possible. Uh, and so, um, but we don't have to worry about those. We just change the filters or brush them off, whatever. Always remember to de-energize and check and triple check your voltages going to your transformer before you PM them. We throw that in there because uh, I've seen people get distracted for a moment and they're supposed to disconnect a load or disconnect a circuit and somebody distracts them for a second and they stand there with their tool in their hand and they forget they hadn't already done it and they go back and go to work and I've seen people get lit up pretty hard for that. And I've done it myself a couple of times on changing out contactors, but always make sure your power's off. But if you're doing a natural convection, you shut the power off, check it with your meter, check your meter, make sure it's good, and then go brush everything down. But sometimes the natural convection isn't enough, and so they sometimes have to add forced air fans for additional cooling. Um, that way they can reach the maximum load rating. If you're not pulling a full load, you can get away with a little bit on cooling. But if you are pulling a maximum load, you can need to have that cooling working right. Um, we've already talked about air filters. Liquid cooled transformers. Uh, in some of these transformers, they require extra cooling from materials that absorbs the heat from the windings, and it carries it away quickly, and it's moved. Um, Sometimes this circulating media uh, is circulated by convection because it does just like the air. It gets warm, it rises and flows away from the uh, core of the transformer and out toward the outer shell of the container, and cooler oil is pulled up along the core. The outer the outer oil that goes down the outside of the container is being cooled off. It's using convection through the metal housing to carry for the air to outside ambient air to carry that heat off. And so the oil gets cooled a separate on a separate part of its cycle. It heats up and rises, it circles over, and it cools down and falls. And that circulation will get going and will continue to maintain itself by convection, right? But sometimes convection is not enough. Sometimes you need something that will to pump it. You got to get it to roll. You got to get it to carry heat fast and move it out into cooling fins or whatever. We use oil in a lot of these oil cooled transformers. This oil um, is uh, usually a special type of oil that will um, carry heat very well, and it's called polychlorinated biphenyl. PCB. It's very toxic. When you mess with this stuff, you need to make sure you check the SDS, you make sure you're wearing the proper PPE so that if you get any of this on you, that you get it cleaned off properly. You don't absorb those chemicals. It's very, very toxic. Um, PCBs were banned to a large extent, I think pretty much totally back in the 70s, but there's still some around. Um, if I'm thinking of the right thing, but I think I am. Um, One of the reasons it has to be something like that is because it has to have a high dielectric strength. If this oil is easy to arc through, it will start letting arcs carry from the transformer to the shell of the transformer or to ground, and it will burn up the transformer and ruin it in short order. So it has to have a high dielectric strength. Um, and so this Ascarel that I'm talking about is the polychlorinated biphenyl PCB containing oil that we've got to be careful with. If you see Ascarel, it'll throw up a red flag to you instantly. Okay, pole mounted distribution. transformers are mounted. We see them every day. We got to where they're like background noise. We don't even see them on the transformers. I mean, I got one right here at the corner of my yard, and it's I never even look at it. Even the only reason I ever look at it is if my power goes out. So they're ubiquitous, and so these things are mounted on poles, and they power residential and small commercial locations, and they're filled with a special oil that does the same thing. It insulates the metal parts, and the energized windings. It carries heat away from the core to the housing, irradiated away into the air, and then it circulates back around. You can see it here. Here, you got the transformer and the coils, and they're creating heat, and the heat is in the coils and the shell around it, right? The oil is circulating. It's getting heated up one side. It's coming over, going back down the outside casing of the uh, transformer shell of the transformer housing and cooling off. And heat is radiating off of it. So it's easy to say. We had a transformer when I was in the Navy on the ship. We had a transformer that had been there since the ship was built in 1962, and that thing it made a lot of racket, but it was a very noisy transformer, and it created an incredible amount of heat. It would. We would be down there working. We would set our coffee mugs on this transformer to let it, and it would keep our coffee warm. So it was quite impressive, and it had held up for all those years. It was still on the ship when they decommissioned it in 1990. Uh, but that's because the oil that was in the housing of that thing was doing a good job of carrying the heat off of the core and protecting the metal components, protecting the varnish that's on the wires in the transformer. It's another thing that varnish, if it gets too hot, it'll start to delaminate. And when it does, you'll have shorts and arcs, and it'll burn up that transformer shortly. Um, Sometimes you'll see fins mounted on these, and they'll have hollow tubes in them. And you can see in the picture there at the bottom corner that it's those are there. It's got cooling fins with tubes going up, and these things help circulate the oil. Now, instead of just running down a slick piece of metal, the oil circulates through these tubes that are open and exposed to air all the way around. Gives them more surface area to be exposed to, so that they can just shed more heat in the cycle. And this goes back to the one I showed you a few moments ago. It's similar, but notice now there's not a arrow coming down this part. It's going out through the coils, the tubes, rather, cooling tubes, and circulating down through there that radiates off heat. Um, and it shows some of these mounted here. Now these here, if you look at them, they only got one tube on each side, which are each four, it ain't four corners, but four quadrants. And so it will it's not doing that much. It's not circulating that much there, but that amount makes the difference that it needs to keep that transformer in its rated temperature. Um, Pad mounted. These things are mounted on concrete slabs on rubber bushings, and they uh, sit there and do their work there. They're not up in the air. Uh, and So the heated oil in those things will do the same thing by convection. It will heat up, starts to move up. It'll lose the heat to the housing and goes back to the bottom, displaces hot oil. So the hot oil and that rises, and the cool oil comes into the bottom and begins to heat up, and it begins a cycle that we've talked about several times now. Now, if they have fins and radiators on these things, they cool by convection. They take the heat away in the same way we've already been talking about. And radiators will give the maximum surface area for cooling, so that transformer at its rated um, power can operate. And whatever kVA, it has to be able to dispose or disperse that much heat. And so some transformers have thermostatically controlled pumps or fans to circulate air and oil so that the oil continually moves and is cooled to the degree it needs to be. I mean, it would make sense that in the wintertime, you don't really need fans forcing air across those tubes because it's already cold. But you come along in July and that same under the same load, that radiator might burn up. And so by putting a thermostat in there, when it gets to a certain temperature, whenever that time of year is that it reaches that temperature, it will click on a fan and start assisting with the cooling. And here's an example of that. Here's a pad mounted transformer. Got the setting on a concrete pad and it's bolted and anchored down. It has what looks like the old timey steam radiators, but those are cooling fins. Oil comes in at the top rather, and is circulated downward as it cools and goes back out of this into the where the windings of uh, the transformer are to cool them down. And this one's got a lot of cooling on it. A lot of oil going out and down here. 1, 2, 3, 4 banks there, and a bank on each end, probably 4 on the back. You know, that's 10 banks of cooling fins that to keep that transformer cool. So, and it's worth it because transformers are very expensive. So you spend this extra money to protect your investment. Um, Water cooling of transformer oil, it's got a heat exchanger, right? Some large transformers, uh, air don't have good air circulation around them. They're either housed in a room or in a vault or maybe uh, just need that extra boost. They'll have a heat exchanger, a water cooled heat exchanger, and the oil is circulating through the core, and the water circulates through the shell. And as the cool water transfers heat from the hot oil, the oil cools down, the water heats up. The water gets pumped out and sent through a chiller or a cooling tower or something of that nature to take that heat onto the atmosphere. And the uh, oil is cooled down and returns to the transformer core to pick up more heat. Uh, and It's important to keep this thing separate. Here it is. You got a cooling tower up here. All this side is water, and here's the transformer, and all this side is oil, and these two here are interlaced so that the oil has to flow around uh, the tubes in there, or that's got water flowing through them, or vice versa. The water has to flow around the tubes that's got oil in. Either way, the water is picking up the heat and carrying it to the cooling tower. And they don't show all the components here. They don't show the pumps that are pumping the water. They don't show the pumps that are pushing the oil or any of that. This is a very simplified drawing. Uh, but you're not going to move that water up here and through a cooling tower without a pump. Um, so now we've covered the different things in uh, uh, cooling transformers, and it's pretty simple, pretty straightforward. A lot of the transformer names, the model numbers reflect how they are cooled, and you'll have to, if you look in the Theodore Wildey book, there's a chart in there that has uh, the acronym for the different types of heating. And so take a look at that if you can, and maybe get it in your head at least so when you run into it, all the extra letters and a model number will make a little more sense to you. All right. Well, I thank you for paying attention. Um, I hope this was fairly clear. I summarized it and tried to make it straightforward. Um, I'm going to put it online and you guys should be able to pick it up. Talk to you later.